Students, hi, this is Mr. Bob. This is the third in a three-part series videos of helping you build your collision predictor app. If you're watching this video, hopefully you've already completed the distraction part and the reaction part, as you can see on the screen. And now we're building the third part, the braking part, and figuring out the final outcome. So let's jump right into it. Also, obviously, if you're doing this, I suspect you have your systems analysis sheet that you worked on with your teacher in class right next to you. And again, I said this in the first video, if at any point I say something that contradicts something you think you heard your teacher say, listen to your teacher's instructions and disregard what I'm saying here. Okay, so for this third phase, this is called the braking phase. So we're going to highlight on the left here, and we're going to merge these cells, and we're going to type in here braking, and we're going to make that bigger, and we're going to make sure that that is centered, as we've done before, and we're also going to fill it. We're going to fill it with this color, this kind of like pinkish color. Okay, and then we're going to type in here moving while braking on 4. All right. So with moving while braking, we have a couple of inputs. We have an initial speed, and initial is another way of saying before, so just want to make it speed of vehicle equals. And actually, that is actually, in this case, I was mistaken because we're doing it in meters per second. Actually, let me write that in here, speed of vehicle in meters per second. Okay, that's actually going to be a calculation that we already did. So I'm going to put it in this column. Whoops, hold on. There we go. This is the right one. Okay, and I'm just going to refer to the previous cell, the one up there, which is D5. Okay, so we got that. Awesome. After that, we're going to need the final after speed of vehicle per second equals. That's an input. And let's first justify that like we've done before. That's an input. Now, if the vehicle is slowing to a stop, then what's that going to be? That's going to equal 0. Oh, and I'm sorry, I forgot to, we always want to put our units to be super clear. So meters per second is here, and meters per second is here. Awesome. The third input we have, or the third item we have, the third piece of data is the acceleration. So the acceleration while braking, okay, equals, I can justify that. Now, you may have done research. Obviously, go with the research that you found, but in our class, we came up with this idea from the Oregon Driver's Manual that it's negative 4.5 meters per second per second. Because it's slowing down, we put, in this scenario, because it's opposing the motion of the object, and we're going to make it a negative 4.5 meters per second per second. All right, so now we get to our first calculation, which is the time while braking equals. And again, I'm going to justify that, and that's going to be in this center area. Okay, and so what we're going to do is we're going to make this calculation. Now, if you recall, this is a formula, and on the top of the formula is the change in speed or the change in velocity. So any change in quantity is always the final value minus the initial value. So I'm going to put a starting parentheses, that's just above the 9, shift 9 will give you that starting parentheses. The final speed is up here, it's C16 minus, what's the initial speed? The initial speed is D15, so it's this one right here. N parentheses, so that's my numerator in my fraction here. And since I have a fraction, that means I'm dividing. That's my next thing. And then the acceleration is what's underneath there, okay? And so that's C17. So it's C16 minus D15, all that quantity divided by C17. I hit enter and I get this number. And as usual, I'm going to clean it up using the decrease decimals. And meters per second is the value. If for some reason you get a negative time, you want to go ahead and recheck this formula because the time should be positive. Okay. And then with that, we can do the last part of this phase, which is the distance while braking, equals, and I'm going to come over here, right, justify that. That is a distance that we're going to get here. So we're going to put that in purple to keep the same color scheme. This is probably the most complicated formula. And I would say for this formula, you want to key in up here. Notice in the upper left, this is like a bigger window. Helps me see things a little more easily. So I would key in here to watch what I'm doing. So there's two parts to this. The first part is the initial velocity, and that's up here, initial speed, times the time, and the time is the calculation we just did. So that's D18. So it's D15 times D18. Okay, I'm just going to put a little space to just make it easier for me to look at. The second term is the 1/2. So 1/2 is the same as 0.5 times the acceleration. And again, the acceleration is this cell right here, which is C17. And then the final part is you're going to multiply that by the time squared. And so the time is right here, the D18 value. Now, to get the squared aspect of this, there above the 6 is a little caret symbol. So you put shift 6 and you get that little caret symbol. And you just put 2 for the fact that it's squared. Hit enter, and I should get this number. Now, I just want to go over this one more time. Look up here where my cursor is and just double check it because this is easy to make a mistake. I've done it numerous times. I've made mistakes, and you want to just double check. If it looks good, if it seems like a reasonable number, then you go ahead and make the decimals look more reasonable. Put meters there. Awesome. Okay. So now we've done the 3 phases. Now we got to wrap this all up by doing just a couple final things. The first thing you want to do is we want to figure out what is the total stopping distance. Okay. And so over here, and this is an important part. So I'm going to put this total stopping distance. I'm going to put this in bold. I'm going to make this font bigger. And I'm going to also highlight all these cells because I think this is pretty darn key. All right, because this is we're getting to the final part of comparing 2 values here. So I would again, you can use different color schemes if you want. I'm going to use something like bright yellow. To get this value here, what am I going to do? The total stopping distance really is the sum of the distraction distance. So it's that one right there, E7, plus the reaction distance right here, E12, plus the braking distance here, E19. And I'm going to make this bold and bigger like I made. And I'm also going to merge these cells together so it just really kind of stands out. Okay, so I've got the total stopping distance. Now, underneath there, I want to list the distance to the object. Whatever scenario you are working with, there was some initial distance to the object that we need to compare this to. Okay, so again, I'm going to make this bigger, 14 point. And this is an input, so I'm going to put this in green. And I'm just going to put, in this case, 60. Oh, by the way, I forgot to put the units here. That's really key, 59.5 meters. So let's go back up here, quickly put that in, bold it as well, so it's consistent. Put the same font size. And I'm going to do the same thing with this. It's going to have the same font size, 60. Okay. All right. So there we go. So we've got distance to object equals. Let me go ahead and justify this guy. Total stopping distance equals. And so the very last part here is we're going to write an outcome, or we're going to have the spreadsheet do something a little more sophisticated. It's going to determine an output depending on having it compare the 2 values, the total stopping distance to the distance of the object. So here we go. If you look, so do that, we write an if statement. So we write if up in parentheses, and we're going to compare the stopping distance, which is cell E21. And I'm going to write less than the distance to the object, C23. So what I'm saying here with this statement is if E21 is less than C23, I put a comma here, quote, that means no collision has happened. So I'm going to write no collision. Now, if E21 is not less than C23, then I want a different outcome displayed. And I would put, that's what I'm putting here after the comma is what the spreadsheet's going to display if those two numbers come out differently. And I'm going to write collision occurs. So if E21 is less than C23, no collision. I'm going to capitalize collision. And and the second statement is if that's not true, and I'm going to put an end parentheses here, and let's see what happens. You know what I forgot? I forgot to put the equal sign in front. So let's do that. Hit the equal sign. And there we go. Notice I have the outcome. I'm going to make this larger, and I'm going to right size this. Okay, awesome. Notice what happens here. Let's go back and let's just change an input. I'm going to make this smaller just to make sure this is working correctly. I'm going to change the input to be slightly, the vehicle's going slightly faster. I'm going to put 32 miles per hour. Notice automatically it updated a lot of the parameters. And notice what happened here. Now the stopping distance is 65 meters, which is greater than distance, and this message changed. So this outcome statement is working correctly. And there you have it. You have basically completed the Collision Predictor app. Congratulations. One tidbit of humor to brighten your day. What sort of food does a barbershop serve in the winter? Cold cuts. Yes, I'm sure several of you are laughing out there. Please take care of yourselves. I hope this was helpful and have a great rest of your day. Thank you.